Hi everyone, I'm Madhumitha Raj. Today I'll be presenting on the topic Security Analysis of Windows Subsystem for Linux, or which is known as WSL commonly. So this presentation explores its vulnerabilities and what mitigation strategies can be applied to make it more secure. The motivation behind this topic stems from the rising adoption of WSL in development environments. As it emerges Linux capabilities with Windows system, it increases complexity and potential security risk. So the hybrid nature of WSL makes it important to analyze its vulnerability and understand how it can be secured. So now we'll look what does WSL stand for. So WSL is a compatibility layer developed by Microsoft that allows user to run Linux distributions natively on Windows. So this has two versions. So WSL 1 used a syscall transition layer while WSL 2 uses a real Linux kernel running in a lightweight virtual machine. So this has transformed how cross platform development and testing are done. But from a security perspective, it introduces new challenges too. So now let's see the relation to the course with the topic I have chosen. So the topic is directly related to our courses as it touches on several operating system concepts such as process isolation, system calls, virtualization, and system file management. Understanding WSL helps us see how OS security boundaries can be challenged in hybrid environments. It also connects with topics like sandboxing, access control, and monitoring. So now let's look on the architecture overview of WSL. So WSL has two architectures. WSL 1 converts Linux system calls into Windows system calls, which means that the Linux environment is tightly integrated with the Windows kernel, whereas WSL 2 on the other hand runs an actual Linux kernel inside a managed VM, which is a virtual machine. So both allows interaction between Linux and Windows file system and networks, which has implications for security. Now, let's look on the literature review. So, various studies and security analysis have highlighted multiple vulnerabilities in the Windows subsystem for Linux or WSL. One key concern is its access to the Windows file system, which can potentially expose sensitive data. Another issue is the lack of strong isolation between WSL and the native Windows processes, so raising the risk of privilege escalation or unauthorized access. Additionally, certain network activities initiated within WSL can evade traditional Windows based monitoring tools, creating blind spots for system administrators or security teams. So, in terms of research, organizations like CrowdStrike Labs have conducted in depth analysis on WSL's internal architecture and its potential attack surface. Microsoft have also published best practices and hardening guidelines to help mitigate these risks. Furthermore, several CVEs have been reported detailing specific vulnerabilities in WSL components, which emphasizes the importance of continuous monitoring and proactive defense. Now let's look on the mitigation strategies. To reduce security risk associated with WSL, several mitigation strategies can be implemented. First, using WSL 2 is recommended over WSL 1 because it offers better isolation through a lightweight virtual machine. Next, keeping both Windows and WSL environments updated is critical to ensure the latest security patches are applied. Next, we can also use access control mechanisms like app locker or group policy to restrict what actions WSL can perform. In addition, implementing monitoring tools can help prevent unusual or suspicious activity among from WSL processors. Lastly, network segmentation can be effective in limiting the potential impact of WSL based attacks by isolating traffic from critical systems. Now, let's look on the best practices to secure WSL usage. Alongside technical mitigations, following best practices can greatly enhance WSL security. First, avoid running WSL with administration privileges as this can lead to unnecessary risk if the file system is compromised. If WSL is not required in an environment, it's best to disable it entirely to eliminate its attack surface. Also, care should be taken to prevent exposing sensitive window files to the WSL environment. Equally important is a user education. raising awareness among employees or developers about the potential risk of WSL and enforcing clear usage policies can help maintain a more secure setup. Now that we have covered vulnerabilities and mitigation techniques, let's take a moment to look at the broader discussion around WSL and where the future environments and improvements can be made. So, although there has been some meaningful research into WSL security, it's important to note that this area is still young and evolving. As WSL continues to grow in popularity, more academic research is needed, especially in areas like formal threat modeling that can help us better understand and anticipate potential attack vectors. Another key gap lies in security tooling. Most exciting tools are designed either for Windows or for Linux, but very few are tailored specifically for the hybrid nature of WSL. Creating tools that are aware of this unique architecture would go a long way in strengthening security. Lastly, there's a growing need to integrate logs from both the Windows and Linux sides. A unified monitoring approach would improve visibility, help detect threats faster, and support more effective incident response in Windows where environments are like and WSL is being used. These areas present exciting opportunity for further research and development as WSL continues to evolve. These are the references I have used throughout the presentation. These include the academic papers, official documentations, and security research reports that support the information I've shared. Thank you.